Welcome everyone. My name is Marta and I work for DataArt company. We should have met all together in 3 cities actually, Zielona Gora, Katowice and Wrocław, hosted by Java user groups. However, due to we had to redirect this event to online streaming. But anyway, I'm really glad that you decided to join us and I hope you are going to enjoy today's webinar by Marharyta. And I wish you all to stay safe and healthy, and let's hope that soon we will organize a live meeting. Now I would like to give a voice to Sebastian Rabej.
Hello, I would like to welcome you all, audience from Silesia, Zielona Gora and Wrocław groups, and everyone who came without connection with those. We are really glad that you are all here with us today. We all want to thank company DataArt for support in organizing this event. Without their help, we couldn't do that. After this talk, you will be able to ask some questions. To do so, you just need them, write them on the chat on the YouTube. But Marharyta will read them just on the end of the speak. I'm really excited to this talk, so I will not let you wait any longer too. Marharyta, the floor is yours. Enjoy.
Thank you, Sebastian. It's a great pleasure to be here and to talk to you. Actually, I wanted to meet all of you in person, but we have what we have, so let's start. Today we'll talk about how to build microservices with Kotlin in gRPC. Actually, it's an interesting stuff, and I hope it will be useful for you, especially if you write microservices and you like Kotlin and you work with some high load. A few words about myself. My name is Marharyta. I work as software engineer at Wix. Maybe you heard about this company. We are doing a pretty nice site builder. And I'm also an active community member. I organize different meetups, conferences, and so on. Sometimes I write something in Medium and Twitter, so you can follow me and read some funny stuff and comment if you want. I have one really important thing you should know about me. I like boxing very much. So think twice before asking tricky questions, because one day I'll be able to come to Poland and you'll see the consequences. Of course, it was a joke. I won't hit anyone, but be aware and keep safe. So let's proceed. What will we talk about today? First of all, we discover what it is gRPC, because not many people know what it is. Then we'll implement some simple service using this technology. After this, we'll rewrite the service using Kotlin and coroutines, and then we'll have a look into some interesting Kotlin libraries that can help us and make our life easy. So let's proceed. First of all, in the very beginning, if you start your career 5 years ago, or 7 years ago, or 10 years ago, you probably wrote monolith. And actually, monolith was the only solution for many years. But at some point, people started to investigate. We find some drawbacks in monolith, and we split it into a lot of microservices. And now almost everyone is doing microservices. So I usually, during my presentation, ask the audience who writes microservices today, and there are a lot of people who are raising their hands. And why do we like microservices so well? Because microservices rock. First of all, we can be an independent, means that one team can work on one stuff, another team can work on another stuff, and you cannot depend on anyone. You just define some contract and so on. You also can be very scalable with microservices, because sometimes some services are not very heavy and other services are very have some high load, and you can like scale it easily and to decide which services you need on like the 5 instances and which service you need 1 instance and or 500 instances. And it's cheaper than scaling the whole monolith. You also can choose the best suitable tool, because one microservice can be written in Scala, another in Java, another in Groovy, or maybe Python, or actually Node.js, or whatever you want, and it will work together because you don't care, you just communicate. And of course, parallel development, because you don't wait for some feature in your monolith, you just can write whatever you want in your microservice, and you might not be blocked. So there are a lot of benefits of microservices, but we cannot talk only about pros. There are some cons. And the biggest issue in changing a monolith into microservices is changing communication pattern. What does it mean? When we were talking about monolith, we only had some functions, some services in one server, one monolith, and you can use it, and it's always under your hand. But sometimes when you're switching to microservices, you need to deal with some network, because one microservice might be on another server, and another could be on some different continents, different country, and it takes time, and you need some network. Network is something that is not reliable. And finally, you get some problems that you never had before when you were talking about monolith. By the way, who said this quote? This is not my words. This pretty famous quote of Martin Fowler, a very smart guy. So if you want to learn more about microservices, about migration of monolith into microservices, you can read his articles. So let's proceed. The most common way to use microservices is communicating via REST over HTTP1. And probably most of you is using HTTP1 and REST today. And at Wix, we're also doing this stuff for client-side communication, and we are happy with this. But what the problem could we have with this? At Wix, we have 160 million of users, and it's going up and up, especially during this quarantine. We had a lot of new users every day, and it means that we have a lot of new requests, a lot of new sites, and our loads of our services is higher, and that's mean that we need to buy more and more servers, to pay more to Google Cloud, to pay more to Amazon, and so on. And actually, it costs money. So the more money your company spends on the infrastructure, the less money it remains, and the less money it can pay to you. I am not happy with this. I want to be paid more and more money. So maybe the way is somehow to reduce your costs on the infrastructure, on some clouds, and to spend it on something more interesting. So let's think. One of the possible solutions could be using gRPC. So let's discover gRPC, what actually it is and how it can help us. First of all, what does gRPC stand for? You can all understand that gRPC is an acronym because it's not some random full letters, but it's like special full letters. When I heard about gRPC for the first time, I had a look into some interesting talks of developer advocates from Google. And what I found out that gRPC means gRPC remote procedure call. It's recursive acronym and it sounds stupid. After that, I don't know who exactly, maybe Google, some managers, maybe SMMs, but maybe developer, they came up with an idea that it's a stupid idea. So maybe we need to change it somehow. And what they did, they created a file, and each new version of gRPC has a new meaning for first letter. Actually, it's not such useful information for you, just for fun. But now you know that the first letter of gRPC is new, each new version of gRPC. That's what about G. What the hell is RPC? Actually, RPC, it's not a new technology, it's not a new concept. It's a remote procedure call, pretty well-known concept from like 10 or 12 years ago. So in distributed computing, it's a situation when your program, when some procedure is executed in another space, another environment, another server, but you treat it as it's your own, like it's your local function. RPC is not new, but RPC is RPC implementation from Google, which makes life easier and and helps us with writing microservices. So how gRPC actually can help us? Because gRPC has some features. First of all, gRPC uses HTTP2. Not a lot of people know about HTTP2. So let's take a look a little bit into HTTP. First of all, let's have a look into HTTP history. In 91, it was HTTP 0.9. Then we have HTTP 1.0, then HTTP 1.1, and it was in 1997. And after this, no progress, and still no progress, and maybe they're not alive. And at some point, in 2015, HTTP2 appeared and said that he is alive. So of course it was a joke. They it wasn't suddenly. HTTP protocol has a lot of people working on it, and they delivered pretty good thing. But what I wanted to show you that the whole internet changed, and most of people today are still using HTTP 1.1, the protocol from 97th year, and it's not cool because we need to step in the future and use at least HTTP 2. But HTTP 3 is also appearing, and you should probably take a look into it. So why is HTTP 2 so cool? First of all, finally, we have single TCP connection. If you know that HTTP 1, every request we open new connection, then it was closed. You can actually make it keep alive, but there are some other problems with timeouts and how to configure them. And with HTTP 2, you just always have this TCP connection opened, and you can use this all the time. So as far as we always have this TCP connection opened, we can use it in streaming, like in client streaming and in server streaming. So you don't need WebSockets anymore because you have this TCP connection opened all the time. And you can also have flow control in HTTP 2. What is it? Sometimes your server is very cool, and it can handle a lot of requests, and it can spam a lot your clients. But your clients might not be very cool and might not have a lot of capabilities to handle all these requests. And it may have that you make your clients down. So flow control helps you to control this situation and to request some amount of this request to your client, and then when your client will cope with this, it will request more. So that's enough with HTTP 2. There are a lot of cool features, but it's not the talk about HTTP 2, so let's proceed. gRPC also is supported by multiple languages, and the more and more languages are appearing. And even if your language has no support with gRPC for now, you can develop your own library and make support for gRPC in your language. And one more cool feature of gRPC is binary. It's binary because it uses Protobuf. Actually, it's not only because of Protobuf, but because of HTTP2 is also a binary protocol. Because when we are using HTTP1, we are just sending strings. Strings are expensive. When we're using HTTP2, we actually send bytes, and the bytes are very cheap. So we are using Protobuf to compile your messages into some binary data. and then you use HTTP2 to transfer it to between your client and server, or between your servers. So having all these features, gRPC can help you to make your communications more efficient. And if your communication is more efficient, you can save time and save money on your infrastructure, and actually can be more happy. So as I already told you, gRPC supports a lot of languages, and it supports Java. So Java likes gRPC because there is an implementation of gRPC in Java. In Wix, we have some small problem. Like we also love gRPC. We like use it everywhere. But in order to use gRPC, we have Scala, and Scala is not supported by default, so we need to use some external library. This library is called Scala PB, and it helps us to make our gRPC communication more easily to work with. So that's about Wix. But at some point, we find out that the future lies in one more language, and it's called Kotlin. And maybe it would be nice to use this language in our infrastructure. So what we were thinking, how to make Wix using gRPC with Kotlin, and if it is possible or not. And that's how this talk appeared, and that's how my investigation appeared. So finally, we've discovered gRPC, and let's go on. So protocol buffers. I've told you a little bit about Protobuf, but I'm not sure that a lot of people know what it is, so let's have a look into it. Actually, protocol buffers is a mechanism for serializing structured data. So it's like XML or JSON, but smaller, faster, and simpler. Let's look into it. So in Proto, you have this pseudo language, and you can define some proto file. In the screen, you see this sample proto file. We have service greeter, and we have some RPC call here, and you say that your RPC call has hello request and returns hello reply. And hello request has only one field name, and hello reply has one field message. Pretty simple. And when you define this proto file, Protobuf is just compiling, and you receive some classes, some data structures in the language you use. This slide, you can see only officially supported languages, but there are also a lot of custom-made libraries, open source libraries for gRPC, not from Google. So there are more and more languages. And that's why it's very cool. So let's a little bit summarize. As far as we are talking about Java and Kotlin and other type-safe stuff, our Protobuf can be type-safe, because when we are compiling our proto file into Java classes or Kotlin classes, we cannot use them improperly, because our language is statically typed and you cannot violate it. You also cannot violate the schema, because your methods and your services are also compiled into interfaces in Java or Kotlin, and you want to send something else instead of your required request, and you cannot return something else than your required response. So it's a better thing than just sending JSON and parsing on client side and have no idea what it could be. There's also a good thing that deserialization is fast. That's only bytes. You also could be backward compatible, because in Protobuf version 3, which is used in gRPC, all of your fields in your messages are optional. And it means that you can easily add new messages, and you can easily duplicate old messages, and you'll be still backward compatible. But the one drawback of Protobuf is lack of human readability. I mean, if you want to debug and you'll find this proto message in between, sending between your two servers or client and server, you'll have no idea what it is because it just bytes and you need to convert it. So that's all about Protobuf. I think I'm talking too much, so let's do a little bit code. So let's implement the service. I'm a little bit fan of Star Wars, so I decided that I need a Death Star. Death Star, if you don't know it, just something that can destroy the planet. So I want this tiny little Death Star to be implemented. I'm a little bit lazy person, so I implemented almost the whole Death Star, except one part that we'll implement together. So let's a little bit discuss what do we want. First of all, we have one simple flow that user can join our Death Star. So how it happens? User join our Death Star service. Death Star goes to the planet service and gets all planets of our universe, returns it to Death Star, and repaint it to our users, so our users will see these planets. Then our customers, our clients go to log service and subscribe to logs because we want to see some logs, what's going on, who joined and who destroyed some planet. And we also subscribe for some scores in order to see the leadership board. And from time to time, when someone destroyed some planet, will get updated in our logs and in our scores table. The another flow is when user destroys planet. So how could this happen? Client goes to our Death Star and sends request that I want to destroy some planet. If his request was successful, we go to planet service and destroy planet. So we just remove planet. But there is one tricky thing, as we don't want our universe to die at all. The new planet is born, and we return this to our Death Star service. And we also log everything, and we update scores, because if some client removed some planet, he or she gets some score. And all the time we update our client about some updates and logs, scores, and repaint the current situation in our universe. Looks pretty complicated. Let's implement. First of all, we have our proto file. You can see here that we have this Death Star service and only one method destroy. This method receives stream of destroy planet request and returns stream of planets. So what we can see is our method destroy, it is a bidirectional streaming. So our client, he just subscribes to our Death Star service, and then he can use in one TCP port, send a lot of requests, and he all the time receives some planets asynchronously. And here you can see the messages. Here's planet, pretty simple, some planet ID, name, weight, and image, some message, and destroy planet request, just username, planet ID, and weight. After we define some proto file, you'll see some magic called compilation, and we'll have these classes in Java generated. And so let's go into IDE and try to code something. Yeah, so we add some server and we can code. So I already prepared almost everything here. So first of all, when we first join to our Death Star service, we need to subscribe. So we add our client into our listeners, and we get all planets from our universe and paint them. So here it is. We see here callback. And inside this callback, we just send our planets to our user because it's streaming. So as far as you can see in the signature of this method, we receive stream observer of planets, and we also return stream observer of destroy planet request. So we need to return stream observer because it's not one call that you just have request and response. It's streaming call, so you have a lot of requests and a lot of responses. So here it is our stream observer of responses. And in this callback, we can decide what to do with our destroy planet requests. So here we just get the destroy planet request, and actually we can destroy planet. So first of all, we will actually destroy planet. So we are removing planet, but you can see sometimes the planet remove cannot be successful. So only in case of success, we are doing the next part. If planet was successfully deleted, we should update our scores. So add score. Then if planet was when we score it, we should log it. After that, we should generate new planet. And when we generated new planet, we need to log it. So yeah, sorry, I was told that I'm not sharing my screen. So what we just did, let me comment everything. So it was get all planets. So you see here that we are getting all planet. And then you see that we returned this stream observer, and inside the callback, we removed planet. Then we added score. Then we destroyed planet, generated new planet. Then we logged that we destroyed planet, generated new planet. After this, we logged that we generated new planet. And after this, the last thing that we should do is to notify everyone. So now we are ready to start this application. So you can see that we have like 5 microservices. First microservice is, they haven't started yet, sorry. So here we have this client starting. Unfortunately, I'm using Vaadin because I'm not good at front end. And all other microservices are written in Kotlin. Yeah, you see that this is the star server. Here we have score server, log, and planet server. So let me go to another screen. And now we can join our service. So we see that it works. Our user test is here, logs are working, and we can destroy some planet. We see that our logs are updating and our score is also updating. So thanks God, it works. Let's return to our presentation. So well done, we are done. And now let's talk a little bit about what's wrong with this implementation and how can we do this better. If we look at the whole destroy method, it looks this way. And there is one thing I don't like about this code, it's this shape. It's pretty nice shape with a lot of callbacks, and this situation is called callback hell. So callback hell is not a good solution. And what we did, it's not a good solution, but unfortunately, it's like for many years, it was the only way to work with gRPC and Java, unless there were some more useful libraries. So how can we fix it? The first question I asked myself after doing this, why don't we use futures? We used a lot of callbacks, some stream observers, but maybe there is a way to use futures somehow. And yes, actually, we can use futures. So let's return to our, let's return to our screen, to our code, and proceed. So it was like an implementation called old gRPC test*. Let's go to another one. It calls future gRPC test*. So in this way, what changed? Before this, we used some planet stub, score stub, and load stub. It just stubs on your other microservices you want to use with simple stubs. But in this example, we'll use future stub. And instead of dealing with stream observers, we'll have futures. So we'll do the same thing, like f get all. So we get all planets from here. After this, we you see that now we launch a coroutine here because we want to make it like in separate thread, like not in separate thread, but separate and asynchronous. And then we'll start with another thing. As far as we have bidirectional streaming, we still are working with stream observer, and we need to return this stream observer. So it's the same as in previous one. And inside the stream observer, what do we do? We first of all we remove the planet. And you see that here our remove planet request returns future. We can do this, and we can call method and await here. So pretty nice. We just call this await and use remove planet as a result of remove planet call. So we don't need any callbacks. So when remove planet result was successful, what do? We need to update our scores. Update scores. Then we need to update log. And after this, we generate a new planet. After generating new planet, we log that we generated new planet. And after this, we should notify all. So you see here that if we don't need to work with the result of previous call, we just leave it as it is. If we want to wait and to use somehow the result, for example, here, the new planet, we call method await, and we don't use any callbacks at all. So code looks a little bit better. In order to start using future implementation we need to change it here. So you see that here we have all the star service implementation. Now we should have future the star service implementation. So everything is fair. We are stopping. And also stopping this process. And we're starting our application again. So we see again that our client starts. And when our client will start, we'll have two other services starting. So while this is starting, we can talk a little bit more about the code. So here you can see this method await. And yeah. So yeah, and now you see that we started our application again, and we can again join it, and we see that everything worked. Hopefully, yeah, it works, and we still can kill some planets, and new planets are generated, and everything is logged here. So let's return to our presentation. So yeah. Now the destroy method looks this way. So we don't see this awful shape as it was before, but it's not bad, but it's still not the thing that we wanted. There is also a way how to make it better. So we can do it better. So here comes the next step of improvements, gRPC and coroutines part 2. So who we are? I guess the people who joined our session are those who are Kotlin developers at the time, or maybe want to be Kotlin developers, or just look into Kotlin. So actually who we are Kotlin devs. And what do we want? We want to have channels. Actually, doesn't mean that channels, but some primitive, some mechanism to get rid of our stream observer at all. But unfortunately, we cannot do this with existing implementation. We need some new hero. And here comes this new hero called gRPC Kotlin. We can use this library in order to make our life better. So let's return to our code. Yeah, we're here. So, and let's go to another implementation. Here it is. So it looks pretty similar. We just have a new step here, and here, everything as it was. But what is interesting in display method? First of all, we don't see stream observers. We see receive channel here, and we see receive channel in returning. So for now, we do not receive, and we do not work with stream observers and callbacks. We work with channels. So first of all, we generate this channel. And also we need to add it to listeners. And then start again. So what should we do? We should get all planets in order to paint them. but we cannot do this without. So we send everyone, we send our client new all planets that we have in our solar system. After this, we should go we should remove the planet. So actually, what should we do? We should go this way. First of all, we get all the planets that we have in our planet tab and send it to our client. Then we iterate over all the requests in our channel. And what do? We firstly remove the planet. Then if removal of the planet was successful, we add score. Then we have this log. After that, we generate new planet. We log that new planet was generated. And after that, we just go over our listeners and notify all our clients that new planet was generated. And at the end of the method, we return the channel. So here it is. Let's go to our DataArt server and just remove this. So we are stopping our applications. Stop it here. Yeah, and we can rerun it. So while it's running, let's discuss a little bit the code. What do we see here? We see that we have now this strange shape that we had before. The most interesting part is that we are iterating over requests. We are working with this channel, and it is some list, some set, or something like this, some collection. Sorry. It looks like it's a collection, but actually it's some asynchronous collection. So this loop is asynchronous. We get here only when we have something inside our requests. And here you just can see that we have only business logic inside this for loop. We only see this remove planet, we see this add score, destroy, new planets, log, and notify all. So I mean, if you read this code, you can understand what's going on. But if you read our the first solution, you won't understand what's going on because there were a lot of noise. So let's test that everything still works. Yeah, it works. Let's destroy some planets. Yeah. So, and so we can close everything. And let's go back to our presentation. Yeah. Now the destroy method looks this way. We don't have any weird shape. We have only business logic here. And that's okay. And finally, we made this doing good. And our that writer is happy. But wait a minute. We have another here. We use gRPC Kotlin here, but we also can use another library called Protobuf. And even here we'll have code more like even better. So you have less stuff here, and you don't have this global scope coroutine starting here. So actually, I like this variant even more. But both this variant and previous variant are looks pretty good and looks much better than the first one. So now we coped with this destroy method. We implemented our star. So let's talk a little bit more about libraries which can be used for Kotlin and gRPC. So when I first started looking into Kotlin and gRPC, I thought that the libraries that I will use there would be like these cool robots that can help you and save you in any situation and even save your life. But the reality that we had these guys who can't even show anyone in 9 episodes. So I was a little bit upset, but we have what we have and we need to work with what we have. So the first library that I faced was gRPC Kotlin, which was successfully used in this talk. It was pretty interesting for me because I thought that it's gRPC and Kotlin, maybe it's something official from Google. But then I noticed that the version was 0.0.2, so it's something like I don't know, it's just the beginning of the library. And there was also a note that please don't use me. Just there is only prototype, it cannot be used in production, it was not tested, so you can use it only in your pet projects or something like this. And when I showed it to my teammates, colleagues, and asked maybe we can use it somehow and try it in order to make them be happier, but be better, they said that they didn't say that I'm stupid girl, but they thought about it, I guess, because we cannot use it and we cannot rely on the library in this configuration. But time passed, I actually used it in some pet projects. I worked with it a little bit and asked some actually the authors of this library. And in a few months, the version was 0.1.2, and I don't know exactly. I guess now it's like something like 0.2, and it's pretty good. And actually, it made me. I almost did the whole demo using this library, and it worked. And actually, I showed you everything in localhost, but when I did this presentation previous times, I deployed it into production, and the whole audience could play with this game. So it works, and it was pretty good. Another library that I noticed was called Protobuf. So it's an interesting name, and but the version was also like 0.1.3, and it was not really ready for production, and so also the story was pretty similar to gRPC Kotlin. But in a year, I guess more than a year, a lot of things changed. Actually, they had a logo and a Slack channel. But this library is also really cool, and I'm propagating to use it a lot with gRPC and Kotlin. So I like it very much because it's very configurable library. You can even configure how you want to parse your proto files, and you can generate some cooler stuff on top of this library. So I like it that if you want some simple solution, you can use gRPC Kotlin. If you want to use some more advanced and more configurable solution, Protobuf is actually what you need. So some other useful links that can be used in the gRPC and Kotlin. First two links are more about Java. It's gRPC Java Contrib and Reactive gRPC. It's two libraries that makes life easier, even in Java, because as I already told you, in Java, you usually use these stream observers and callbacks. But using reactive gRPC and gRPC Java Contrib with some completable features, you can actually get rid of this stuff and make things better. Here you can see another library for serializing Protobuf and Kotlin. It's pretty promising for multi-platform development, and you can also take a look into this. Actually, this is my repository. You can play with it, work with it, and make some pull requests here. And the last link, it's not about code, it's about performance, because what I tell you a lot, the gRPC is more about performance and more about saving your money and your resources. But unfortunately at Wix, we still don't have some cool benchmarks, like some stuff to share with you, because we need some more time to do this. We see that we have a lot of improvements with gRPC, but it's still not enough to make this conclusion. But in this article, you can read more about gRPC and REST versus REST and performance. So where it's better to use gRPC and where it's better to use simple HTTP and REST, or maybe something else. And I hope that one day we'll release all these libraries, both in gRPC, Kotlin, and Conda Plus. And I hope it's going to be soon. And actually, we almost have the stable Kotlin support, because these libraries are going to be released very soon. And time to summarize. There are a few things that I want you to take away from this presentation, because you might not use gRPC or Kotlin in production like in few months, weeks, or years, but I want you to understand that gRPC is something that is useful for effective communications. So you need to use it if you have problems with communications, if you have this high load and you need to work with this. gRPC and Kotlin can be actually used today. So if you're having Kotlin, you can use it with gRPC and be happy. And actually with gRPC and Kotlin, you can make things easier than in Java, because in Java, you have more this verbosity and you don't have these channels, and actually you still have to do some hacky and tricky stuff. Waiting for first releases and for new features. The one feature I'm really waiting for is flows, because you see that I implemented stuff with channels, but channels, they're like hot streams. What we want to do flows, which are cold streams, and use them instead of channels. And of course, all these libraries are open source, and if you want them to be better, you should use them and contribute to them, because there is no way to open source to become better if you don't use it and you don't make some pull requests and then contribute. So do this, and you have a lot of pluses in your karma. And one more, it's the last point on my takeaways. I started adding it like a few months ago. Just don't use gRPC. Don't use it if you don't need it. As I already told you, gRPC is useful for effective communications. So if you have some high load and if communication is something that you're working a lot with and you have problems with it and you want to make it cheaper, faster, gRPC can help you. If you don't have these problems, you might receive new one with gRPC. So choose wisely. And it's time to say thank you, because behind this presentation, there are a lot of people. First of all, it's Ray Tsang, and these two guys who are authors of gRPC, Kotlin, and Protobuf, who helped me with like technical stuff and who developed cool libraries for which I used and showed you. And there's also another stuff like my friends who helped me and reviewed my presentation, make my slides not that ugly and more entertaining. And this guy, he inspires me most of all because he's George Lucas and also Star Wars, and it inspired me to make this Death Star. And of course, it's time to say thank you to you, because I'm really happy you even in this difficult situation, you joined me and listened to me, and I really hope it was useful for you. So thank you very much. Even I cannot hear your applauses, you can do it for yourself. So because you deserve it. Thank you. And actually, it's time to do Q&A. So I'm stopping doing this presentation, and I'm back to my chat. So unfortunately, I don't understand Polish. So I guess there are no actually questions. So maybe you can ask me them in the future, maybe in Twitter or somewhere else. Well, thank you a lot for your comments, and I'm really sorry that I didn't share the screen for the first part of the code. It's like my fault, so I hope you won't be very angry at me, but I guess you developed your imagination a little. So thank you one more time. I'll stop sharing my screen, and be healthy, take care of yourself, and see you soon in person.